Okay everybody, welcome back. This is our second video on section 6.11 of AP Calculus BC, integrating using integration by parts. This is going to be our second video from our first lesson, using integration by parts, part 1. In the last video we covered simple integration by parts, single-step integration by parts problems. In this video we're going to do a few examples using multiple-step integration by parts. This is a technique that's typically used with when we have a second or higher degree polynomial that's paired with either an exponential or a trig function. Okay, here's how it works. What happens? We apply simple integration by parts like we did last time. But what happens now, instead of our integral of v du becoming something that we can just integrate by antiderivatives or whatever, we're going to get another integral that requires integration by parts. And so we're going to keep applying integration by parts until we get to the point where we can just go ahead and use an antiderivative to find that integral at the tail end of the problem. All right, let's go ahead. We'll look first at example 6 here. Find the integral of x squared e to the x dx. So we've got a polynomial and an exponential using LIPET. That means that our u is going to be x squared, and our dv is going to be e to the x dx. And then I take my derivative of my u and my integral of my v. And so this is going to be equal to uv, so that's x squared e to the x, minus the integral of v du, 2x e to the x dx. I'm going to factor the 2 out in front here and just make this x e to the x dx. Now this is an integral that I can't find by just using the antiderivative, so I'm going to apply parts again. I have a polynomial times an exponential, so we're going to use u equals x, dv equals e to the x dx. If you feel like subscripting these u's and v's because they mean different things at various different times in the problem, feel free to do that. I'm just not going to. Alright, and now we have our u, our dv, our du, and our v for this integral. Well, everything else stays the same. We've got this x squared e to the x minus 2 times. And now this is the integral of our new u dv. That's going to be equal to uv minus the integral of v du. Oops, got an extra dx there for some reason. And there we go. And now this is something that we can take the integral of by just using basic antidifferentiation. That's just going to be e to the x plus a constant. And now I want to distribute the negative 2 through the parentheses here. And there's our integral. If we wanted to, since all of the terms have an e to the x in them, we could factor an e to the x out and write our final answer like this. I think I'm going to take either of these as a final answer here. Alright, and that's all it is when we're doing multi-step integration by parts. Let's go ahead and we'll do another example. The integral of x cubed sine of x dx. And one of the things you'll find about these multi-step integration by parts problems is the larger the power of the polynomial, the more steps that we need to complete. And so this one's going to be quite a few steps for us since we're starting with an x to the third. So again, polynomial times trig function. Polynomial is our u. Excuse me. And dv is going to be sine of x dx. And so then du is 3x squared dx. And v is equal to the opposite of the cosine of x. Alright, so this is equal to uv. It's negative x cubed cosine of x minus the integral of v du. which is negative 3x squared cosine of x. I'm going to take that negative out in front and make this sign a positive. I'm also going to take the 3 out in front. And so this turns our integral into that. And now guess what? We need to use integration by parts again. So I choose my new u and my new dv. Take the derivative of u, take the integral of v, and then this is going to be, let's see, 3 times the quantity uv minus the integral of v du. Again, I'm going to bring the constant out in front. And then I need to apply integration by parts again. Actually, before I do that, I'm going to go ahead and get rid of this set of parentheses. And then we need to apply integration by parts again. Now the u is equal to x, and dv is equal to sine of x dx. So du is dx, and v is negative cosine of x. And so we've got negative x cubed cosine of x plus 3x squared sine of x minus 6 times the quantity uv, which is negative x cosine of x, minus the integral of v du, which is negative cosine of x dx. Since I'm subtracting a negative, I'm just going to go ahead and make that a plus. And then the integral of cosine of x is just sine of x plus my constant. And now the last thing I'm going to do is distribute the minus 6 to get rid of those parentheses. And boom, there's my integral of x cubed sine of x. If you feel like that felt a little tedious and a little cumbersome to use multi-step integration by parts on a problem like that, you are going to be so happy with the second part of our next lesson. All right, that brings us to the end of using integration by parts, part 1. We'll come back and talk more about other integration by parts techniques in our next videos. All right, have a great rest of your day, everybody. Enjoy yourself, and we'll see you next time. Bye-bye.